Good morning, welcome to this class. Today's topic is PCG is a algorithmic creation of game content with limited or indirect user input. It refers to computer software that can create game content on its own or with any manual or human players. So let's see about the importance of procedural content generation. So it has an endless variety. So number of personalized generation can be affected, cost efficiency and increased replayability and dynamic experiments could be done. Basic principles of procedural generation. First is randomization. It uses random inputs to create unique game elements each session. The modular design uses reusable components to streamline level creation and asset management. Algorithmic generation employs algorithms to generate complex terrains and environments. Parametric tuning adjust parameters to control variability and influence generated. Let's now see about randomization for unique game experiences. So dynamic levels creates endless game environments by utilizing algorithm to generate different level layouts each time a player engages. So it helps in replayability and player engagement and randomized assets. It implements randomization techniques to generate unique game assets such as textures, models, and sounds. Consume that each player's experience is distinct and fresh. Uh, Next is the randomized content generation. The game levels are developed and creates endless unique game levels, providing players with diverse experience and challenges tailored to their skill levels. Item creation, randomized items generation system can calibrate gameplay by creating variety of weapons, armors, and consumables. Modular design helps us to develop a game in modular structure. So various tools are asset pack, procedural tools, data-driven approach, and dynamic prefabs, level templates, and version control. Next, we can see about procedural algorithm. It relies on rules, randomness, and algorithm by defining a set of par- parameters or rules. The algorithm can generate content based on the guidelines. Randomness is often incorporated to ensure that the content remains varied and separate. So let's see about how the PCG works. It often uses combination of techniques such as random number generators, noise functions, and EM systems. So RNG creates varied content, which is often used for variability. Noise functions provide used to generate natural organic textures with arrays. This is not right for generating organic structures such as trees and plant life. So PCG may sound random, but it is guided randomness, ensuring varied. Next, we can see about algorithms in PCG. So for RNGs, the example is random span location, loop drops, and types. For Berlin noise, the example is terrain generation caves. Next, we can see about cellular automata. So a grid evolves based on rules and it used in cave generation dungeon layouts. And Lindenmeyer's system recursive rules that simulates natural growth, generating plants, trees, and even city layouts. Next, we can see about grammar-based generation. It uses a set of rules like grammar in language to build structures. Examples are quest, storyline generation, and cities generation and dialogues. Skyrim's Radiant quest system is an example for the quest generated with changing NPCs locations. Next, we can see about the wave function collapse. So it is a constraint-based algorithm that generates maps texture without breaking design rules. So for dungeon maps, custom layouts, this kind of wave function collapse is used popular in indie PCG tools for dungeon level creation. Next is the search graph algorithm. It uses A star algorithm. It is not just a pathfinding algorithm, but also used in dungeon layout generation. And depth first search and breadth first search can be used for maze or level generation. Next, we can see about genetic algorithms, evolutionary algorithms. It evolves solutions over time using mutation and selection. In BCG, it creates new weapons, enemy types, or game strategies. So it is useful for research in evolving game levels or NPC behaviors. So some of the noise function in game design is Berlin noise, simplex noise, white noise, Voronoi noise, fractal noise, and Laplacian noise. These are the various noises which are used in game design. So the example of noises, white noise looks gives a texture which is repeated at a certain level, and Perlin noise used for random environment with bumps and mountainous ranges. And simplex noise is plateau with rough surface, and Laplacian noise is used for peaks and mountainous terrain. Next is the fractal generation technique. So the fractals could be used for generating terrain when it can simulate cloud, and texture creation can be done using the fractals, and level design can also be done using fractals. See about tile-based generation methods. So these are flexibility-based methods and which can be reusable and which gives performance and can be used for simplicity because the execution flow is tile creation, placement logic, level assembly, and testing. With these thoughts, we can end today's class. Thank you, students.